All right, hey everybody, we're back here again. New approach, new approach, because I messed it up, messed up the last one. If you watched the last video, a few things I said in the last video that I want to sort of go through quickly because I got a meeting at 2:15, got to get to it. A few things about this, the square is the bottom here. So yes, you can totally prove that this here, this length here, whatever this is right here, okay, that's got to be half of whatever AB is here, okay? The diagonals of a square are going to meet at kind of like where the midpoint, projection of the midpoint is here. That can be proven through all these triangles will have to be congruent, just putting in here. So then here plus this, these would be congruent by CPC. Anyways, yes, this is 15. Okay, so that's important because here we have this triangle right here. We got to get OE. Okay, this is all just one triangle here where this here, technically this is an altitude to the hypotenuse of a right triangle. But the key thing is here, and maybe I'll break it apart right here. VO, and then maybe we'll call this Y right here. VOY is this, okay, is a right triangle. So I got carried away with this, and I must have made a mistake somewhere. I don't know where, of triangle VOY that I have here, where I was realizing, well, what we're trying to do is trying to get the distance to this plane right here. This triangle is plane. So that'd be the perpendicular. That'd be the altitude of this freaking triangle. Check this out. This is what we're trying to figure out. There it is. So I got all carried away because here I have a right triangle. Here I have an altitude to the hypotenuse of a right triangle. We just spent time solving that. And I must have made a mistake somewhere in the video. Please send it to me if you figure out what the mistake I made. I don't know where it was. I didn't get a chance to look at it super long. Okay, I do have a meeting pretty soon here, so I do need to get humming on this because I got another way to solve this, okay? You with me in this one? This one here, OY here, that's just going to be half of it. That's going to be 15. They gave this to you, VO, which is the distance from the top of that pyramid down to the square base. That's going to be the perpendicular segment there. That's why it's distance. This is 20. So we got a right triangle here. We can get the hypotenuse. Yeah, we sure as heck can. This is going to be 15 squared plus 20 squared equals whatever Vy squared is. Maybe I made a mistake on this part here. I'm not sure. 15 squared is 225. 20 squared, I did 30. I did 30. That was my mistake in the last video. Gosh. Mistake here. Okay, now I got it. Now I got what my mistake was. 20 squared is 400. Wait. Yeah, I made a mistake in the last video. I did 30. I did something silly last one here. Okay, anyways, Vy squares, we got this. So 225 plus 400, that's 625. So there are things that keep math instructors up at night. That would be one of them. Okay, 625 it actually is a perfect square. Check it out here. 1520. This is Vy is going to be 25. That is a Pythagorean triple right there. This isn't a 3 to 4 to 5 ratio, okay? We'll just keep an eye on those. You don't even really know that too many Pythagorean triples here. But here, square root of 625, man, this was a lot easier than what I just filmed with for you earlier. Take the square root, 25 is our answer here. So Vy is 25. So now let me try what I was trying to do before. Okay, this is 25 here. So this is going to be 25 minus x. Okay, this here going to be what? Well, this is going to be x here. Let's try to figure out what x is first here. So x here, so 20 is the geometric mean, right? Because this is a leg of a right triangle. This is an altitude to it. We know that this hypotenuse is 25. So we know that 20 is the geometric mean between x, which is what I applied a variable to that one to, and 25. This is just what we were doing last section, right? Section 6.1 here. Let's see if we can solve this one here, okay? So 20 is the geometric mean. So this is going to be a 4 to 5 ratio. 4 to 5 ratio of 20. I know that's going to be 16 there, okay? Right, that's a quick shortcut there, but I can also cross multiply and solve it. 25x equals 400, okay? And what, 400 divided by 25. Let's get that in my calculator, divided by 25. That equals 16, so we're good to go. So this is 16 here. Okay, this is 16 here, and then this is 25 minus x, so that's going to be, and maybe let's clean this up a little bit here. That's 16. This is 25 minus 16, so that's going to be 9. There we go. Okay, so now we want to get what OE is. Here's OE. Okay, and what we know about OE is the geometric mean right here between that segment of the hypotenuse and that segment of the hypotenuse that got created by the altitude to the hypotenuse of a right triangle here. We know that theorem section 6.1, this geometric mean thing keeps paying off for us the fact we spent time on here. Okay, so OE, geometric mean of 9 and 16. And let's go ahead and solve it. The answer is going to be 12 because I have that in the answer key in the back of the book. But anyways, 9 times 16, get used to it. 9 times 16 was 144. We'll do this quickly. Equals OE squared, right? Cross multiply, get that. What do we do to solve for OE? Take the square root of both sides. 144 is a perfect square, and we get 12. Okay, OE equals 12. And there, we have our answer to that one. Man, I'm going to keep that other video online for you, though, so you can see me mess up and be like, I'm just not getting it. But I did it again, and I got it here too, right? So you can stumble, you can get stuck on something, you can be kept up at night on stuff, but ultimately get it, and it pays off. Okay, I'm gonna go take a nap. Bye. Yes.